Buenos dias! I think it's day 10 now, and we are going to go up to the property to finish installing the valve permanently on the west main, and then reconnect some new pipes up at the water tank and incorporating a hose bib so that we can have some water supply when needed up at the top of the mountain. And then finally, hopefully, start chlorinating the wells, right, Tara?
That would be nice.
Tara's got a nice little procedure. We are gonna hopefully not die of bleach fumes because we have 14 bottles of bleach now. We had to recalculate, and then maybe help Jeremy a little bit with some direction on the electrical or whatever stage he's at right now in his house. So we have another beautiful morning with our quick spring. If you see right here, look at that little pond action. It's gonna be probably, what degrees? Like 70 degrees today?
66.
66.
Yeah.
So we're now having to repair this brake, as you know, but after looking up some information, there's a lot we're learning here, and I knew it was going to be a high pressure system because of all the fire hydrants and how high the tank is up on the hill, but I didn't know that they're going to run a different pipe, because I've seen a bunch of the white Schedule 40 pipe they've had laying around, but in the ground, as you see, this blue pipe is a high surge rated pipe, high pressure pipe. And my concern was I wanted to double check before I made an official repair that you can actually glue this pipe to our Schedule 80 fittings, because, well, Schedule 80 is PVC, but I wasn't 100% sure on this pipe. It's blue, which tells me it should be for water and that it should be potable, but it most likely it's C900 pipe, and I've talked to some people and they think that that's what it is. But there's some other high density polypropylene pipe out there and similar that is not suitable for glue. You got to use clamp connections, and even with this stuff you can use some clamp connections. But as you can see, what we found in the barn, whoever set up the system before, and you never should assume, but it looks like they did things pretty legit. And I don't know if back then, 40 years ago, they had Schedule 80. I'm assuming they did, but they use this high pressure pipe, and then in some sections they put Schedule 40, which is not nearly as high as this stuff, but maybe that's why they did some of the concrete. I know they do concrete support for all the surges and pressure. I said we're trying to still decode all this water system, and once I'm positive about what pipe this is, then we're going to do an official fix with either the brass valve or the Schedule 80 valve, which these things are very pricey, but they're nice because this is a true union valve. It's got a union on both sides, preventing having to buy extra fittings like a separate union and then doing a connection from here to there. You'll spend twice as much buying a valve, 2 unions, like I just did. But I want to be prepared for any situation, so that's what we're gonna try to do. So the beveling's for the prevention of pushing the glue out. If you bevel it, it'll trap the glue when you slip the coupling on. You can use a grinder. That was a flat wheel. And then this is just a little 180 grit just to get the oxidation off the PVC. Geez, that's another gouge. Oh, dang it. I'm gonna have to cut it back here. Because that's another gouge. Ah, jeez. Another gouge. This is a big gouge. All right. Let's do that. Put the flow that way because most of the time the tank is coming from this way. Unless we have the south well on, then it can go both ways. But for servicing, if we have it off and the flow is going that way, that'll give us the ability to tighten the seal in here up on the ball valve. So that's the side you want to access that on. Now we don't want to glue with the valve on and accidentally glue our stuff on. So now, I'm gonna make sure that's on first. Make sure that it's gonna fit. Gotta get our pin. Get an idea. Okay, feels good. Manufacturers say go in one motion so that you get a uniform amount. Bang, bang, bang. No puddling. All right, so that's good. Now let's glue. Oh yeah. Nice fit. Now, keep the pressure on so that it doesn't push off, especially with bigger pipe, even little pipe. And then we'll make sure this glue doesn't go on our flange at all. How you doing, baby cakes? You're not looking dirty yet. That looks good. Okay, so I'm no commercial plumber, but I'm sure I can get something stuck together, and that's the main goal here. But what I was trying to find on the internet was the pros and cons for putting in a valve, whether you do a service loop and do a 90, so that if you do 90s like this to that valve, then once that's built to a precise dimension, then you could slide it on to the 90 and you don't have any worries of going left or right, so to speak, versus doing inline. If I go in line, I need to have that pipe in there the perfect length so that when I put this in and take the other side off of this union valve or true union valve, that it slides perfectly right in between. Now, I guess there's more chance of error doing it like this because you have to be precise, which is why I guess you would do the service loop. But if there's more benefits, I'd love to hear them in doing a 90-degree service loop, but I'm trying to save fittings and be more efficient. So what I'm gonna do is glue this pipe in a little longer than it needs to be and then cut it so that I'm perfectly in place to put our new valve, and that's how we're gonna do it. So scream through the YouTube channel and let me know if there's a better way.
It'll be too late.
Okay. So I knew going into this would be the biggest challenge is you want this flange to be parallel with that, or else you can have an unequal pressure, and that's really time consuming in a commercial application, which is why I'm sure is the number one reason why they do a service loop, do a 90, and then they can slide in. But doing it this way, I'm just taking my time and it's sliding in perfect. I put a little silicone grease in here, because it always works good with O-rings. Now that I've test fitted, this is glued, this is not, so I need to mark this so that it lines up directly where it was right now with the glue and not tilted at all. So that's the next step. I'm going to trace it with a marker, take this off, glue it, and then we should be good. So now I'll take that off. And all right, we got to fix some code work here. It was done perfectly. We got some underground direct burial wire inside some PVC. Couldn't be better than that. So what we want to do is upgrade this. You have schedule 40 pipe here, high pressure pipe here, and I don't like these couplings. And not to mention, we all know PVC is not supposed to be in direct sunlight. And so if you have pulley equipment, cover it now, protect it with some type of insulation or a cover, because it'll just degrade. So before we go to fill up the tank and get all our system ready, we want to put in some better pipe, and so we don't have to mess with this again. So we're going to put schedule 80 somewhere down here, because you can see that was exposed to the light for some time. We'll probably go somewhere there, and then I'm going to put a T and put a little hose bib so that when we're up here we have a little water that we can access to clean things and do things. And then yeah, once again we're going to use new pipe all right here. And you could use schedule 40 in this situation, because now we're up on the hill probably about 200 feet up, and so there's a lot less pressure here than there is down there. So I could use schedule 40 and save a lot of money, because the schedule 80 is very expensive. It's double the price, but we want this to last a long time. And if someone kicks it, I don't know, peace of mind for here. We're gonna go with the better pipe, and then yeah, and then later we'll fix this wiring that's hideous. But right now Tara's gonna dig some room. I'm gonna set up, configure the pipe system, and we're gonna get after it, right?
Well, let's go.
All right. Oh, let's show you the inside. So there's inside of a 2.5-inch valve. We bottomed out the other male adapter with a pipe wrench. It's cool working with bigger stuff, because there's like different requirements. As you get bigger, there's different variables, but they want you to Teflon paste the inside and, well, your male adapter as well. When you're 1.25 inches or smaller, you could just do the male adapter. And they also say to use thread sealant on 1.25 inches above versus Teflon tape. And I know there's tons of plumbers out there with your smaller fittings that use both all the time, and they swear by it, and that can get into a big theoretical argument. And I've done both, but if you do proper prep, one should just be good enough, and you put it on right. But so now we're gonna do a little hand tighten, a little Joel wrench, and then we'll take it to, I guess you could use a strap wrench or just a really good pipe wrench. We'll just use a pipe wrench. Take it over here to our little handy vise. It's called the man vise. Right, babe?
The man bite?
The man vise. Just put a little chest into it. There we go. Nice and easy. Nice. Don't fight me. Say uncle.
Say uncle.
Many parents don't realize they should start brushing their babies' teeth.
Almost bottomed out. 1/8 inch.
One more.
I don't want to break it. PVC. It's just PVC.
There it is.
There we go. All right.
Tapped out.
Tapped out. All right. There you go. We finally got it done. It's like 4 o'clock now. We started at, I don't know, 1 o'clock, something.
Yeah.
And you can see it's tilted. We had to tilt it back because I mocked up that first elbow piece off what they had right here, and never assumed someone else had the perfect angles, because it gave me a slight bind and it's going up a little bit, but I had to do that just to make it work, and I didn't have time to go get Schedule 80 fittings to readjust or make that height difference or clocked angle different. But nonetheless, we'll support it nice, and we'll come back and tighten those unions after we let the glue harden up a little bit, because it's going to put even more tension on them, just a little bit. They'll cinch that O-ring in between. And then we'll put our little hose bib there that will be inside the valve box in case we ever need water up here. So we're all dialed in now. All right, so Tara's tightening down the pipes that were from our well, because we obviously, like I told you before, we didn't get all the way down in our well the second time. So this is a leftover pipe.
We hope to eventually get it all the way down there.
Yeah, we want to put it back in. So we're just making use of some downtime since it's too dark to do the chlorinating. We gotta get ready to go home soon. But we're gonna go back inside and help Jeremy, right?
Yeah.
Can't see anything out here. All right, this is how we do it. It's like 9:15 at night. 9:32, and headlamps blinding us. Milwaukee Tower, and yep, just packing stuff so that we can get ready for work tomorrow and see if we can come back Saturday after we do this other little job. I'll keep this here. Yep. So say goodbye.
Bye for today.
Bye bye. Hey, say hi, everyone. Hello. WorknDirt.
Yo, yo, yo!
Hi. Woo! Yeah.